Welcome back to the video, and today I'm going to solve some trigonometric functions and the inverse of the z. Okay, so first we have the cosecant of 3 minus j4. So what I did, I transformed this into a sign. So this equal to 1 all over sine of 3 minus j4. Next, using the trigonometric of sum and difference of two numbers, so I transform this into the trigo function of z plus the trigo of the sum and difference of the two angles. So we have the sine of 3 times your cos, the cos over hyperbolic of 4 minus the sine of the sine hyperbolic of your 4 times your cos of your 3. So using the calculator, so we have 1 all over sine of 3 hyperbolic cosine of 4 minus your cos of 3 times your hyperbolic sine of 4 pi. And here then we just convert this into rectangular form, and we get 5.14 times 10 raised to negative 3 minus 0.036 pi. So let me put here, so it's 5.17 times 10 raised to negative 3 minus 0.036 j. This is the answer for number 1. So next one of our trigonometric functions is the secant squared times 1 plus j. So first, I convert the secant into the cosine. So 1 over cosine squared times 1 plus j. Then I use the identities for the cosine squared, which is the 1/2 of 1 plus cos of the 2 times the angle, or in this case the complex numbers. So we have 2 plus 2j. That's all over 1. Next, I just move the 1/2 to the top. So we have 2 all over 1 plus cos of 2 plus 2j. Next, I convert the cosine of this to the trigonometric functions of the z. So you have 2 all over 1 plus cos 2 of the cos hyperbolic of 2 minus j of the sine 2 times the sine hyperbolic of 2. Then we just use the calculator. So we have 2 all over 1 plus cos 2 times the cosine hyperbolic of 2 minus sine 2, the hyperbolic sine 2 I, then shift complex 4. So we get negative 0.10 plus 0.59j. Next, we go on to the inverse. We have our problem of arctan of 0.2 plus j 0.1. I know we have the short method, but I'm going to use the long method for this. So let's say, or let A equal to the arctan of 0.2 plus j 0.1. Then we just transfer tan to the other side. So you have tan A equal to 0.02 plus j 0.1. Next, I convert this to sine A all over cos A equal to 0.2 plus j 0.1. So we know sine A in an exponential form is just e raised to ja minus e raised to ja over 2j or j2 all over. The exponential form of the cosine is just e raised to ja plus e raised to j negative ja all over j. equals to 0.2 plus j 0.1. Then we cancel out the negative j and we transfer the j to the other side. So we have e to ja minus e to negative ja all over j. Oh, sorry. This will be your e to ja, which is mine plus e raised to negative ja equal to 0.2 plus j 0.1 times j. Distributing the j, so we have eja minus e negative ja all over eja plus e negative ja equal to 0.2 j. So this is negative 1, negative 0.1. Then we just transfer this to the other side. And we get e to negative ja minus e negative ja equal to 0.2 j minus 0.1 times the eja plus e to negative ja. Next, we divide both sides, or we just distribute this first. So we have e negative ja minus e to negative ja equals, now we have 0.2 j e is to negative j, and we have here plus 0.2 j e is to negative ja minus 0.1 e is to negative ja plus so minus 0.1 e raised to negative ja. Then we multiply this by your e raised to negative ja. So we get here e to ja squared minus 1 equal to 0.2 ja to negative 2 ja squared. This will be equal to plus 0.2 j minus 0.1 e is to ja squared, and this will be negative 0.1. Then we put all the with the square to the other side. So we get e to negative 2 ja squared minus 0.2 j e to negative j squared plus 0.1 e to ja squared equal to, so we have positive 1 minus 0.1 plus 0.2. We factor out. Here we factor out, and we have here 1.1 minus j 0.2 equal to e to the ja squared equal to, this will be 0.9 plus j 0.2, and we divide this 1.2 negative j over 2. So we got e to j equal to the square root of 0.9 plus j 0.2 all over 1.1 minus j 0.2. I just directly square root because we have a square here, so I just square root it. And then we let ln both sides. So let me put here. So ln of e is this one, so what it's left is just ja equal to the ln of the square root of 0.9 plus j 0.2 all over 1.1 minus j 0.2. Then divide by j, so we have a equal to negative j ln of the square root of 0.9 plus j 0.2 all over 1.1 minus j 0.2. So we know that a is just arctan of 0.2 plus j 0.1. So our final answer is the arctan of 0.2 plus j 0.1 is equal to negative j ln of the square root of 0.9 plus j 0.2 all over 1.1 minus j 0.2. And we have the last problem for the inverse. So this is the arc cosecant of your negative 0.3 minus j 0.4. Let a equal to the arc cosecant of your negative 0.3 minus j 0.4. Then we transfer this to be the cosecant of a to negative 0.3 minus j 0.4. We convert this into sine, so 1 over sine a equal to negative 0.3 minus 0.4 j. Convert this into exponential form. We have 1 all over e to ja minus e to negative ja all over 2j equal to negative 0.3 minus j 0.4. We divide this, so we have 2j all over e to ja minus e to negative ja equal to negative 0.3 minus j 0.4. Then I divide this to the other side, so we have 2, or multiply, so we have 2j equal to negative 0.3 minus j 0.4 times e raised to ja minus e raised to negative ja. Simplify this further, so you have 2j equal to negative 0.3 e to ja plus 0.3 e to negative ja minus j 0.4 e to ja plus j 0.4 e raised to negative ja. Then multiply this by e to ja, so we get 2j e to ja equal to negative 0.3 e to ja squared plus 0.3 minus j 0.4 e to ja squared plus j 0.4. Then we put all the variables to one side, so I got here, so you can see that. So let me just show you. So e to ja equal to no negative 0.3 e to ja squared minus j 0.4 e to ja squared plus 0.3 plus j 0.4. So let me simplify this much further. So we get negative 0.3 e to ja squared minus j 0.4 e to ja squared plus 0.3 plus j 0.4 minus 2j e to ja equal to 0. So I'll just make it more uniform. So negative 0.3 minus j 0.4 times your e ja squared minus 2j over e ja plus 0.3 plus j 0.4 equal to 0. Then we're going to use the root formula. So e ja equal to negative b plus minus square root of b minus 4ac all over 2a. Then we get the here the a, b, and c. So we get your b is just 2j plus minus square root of 2, this is b squared, 2j squared minus 4 times your a, your negative 0.3 minus j 0.4 times your c, which is 0.3 plus j 0.4 all over 2 times your a, negative 0.3 minus j 0.4. From there, we simplified further, so we get e raised to ja equal to 2j plus minus square root of your negative 4 minus 4 times 0.09 minus j 0.12 minus j of 0.12 minus, or I mean plus 0.16 all over, so this will be negative 0.6 minus j 0.8. Then we further simplified this, so we have here 16 minus negative 9, that will be 0.6, and this will be 0.24. So we get e ja equal to 2j plus minus the square root of negative 4 minus 4 times 0.6 minus j 0.24 all over negative 0.6 minus j 0.8. Then we took out the perfect square here, so this is 4, so j equal to 2j plus minus, this will be 2 all over negative 1 minus 0.6 minus j 0.24 all over negative 0.6 minus j 0.8. We let everything both sides by ln, so we got ja equal to ln of 2j minus 2 square root of negative 1 minus 0.6 minus j 0.24 all over negative 0.6 minus j 0.8. Divide this, and what is left is a, so we know a is just the arc cosecant of negative 0.3 minus j 0.4. So in the end, our answer is the arc cosecant of negative 0.3 minus j 0.4 is equal to negative j ln of the 2j plus minus of 2 square root of negative 1 minus 0.6 minus j 0.24 all over negative 0.6 minus j 0.8. This will be the final answer. Thank you so much for watching the video, and this is my second upload because the first one had some wrong answers and wrong sign conventions. And like I said on the first video, I learned that this is very OT, but with patience and dedication, we will answer all the problems in trigonometric and in the inverse. And see you in the next video.